Hello everyone, my name is Aleksandra and I'm very happy to be here and I'm happy that you're having me here. Yes, a few words about me. On a daily basis, I'm working as a cybersecurity senior analyst for Accenture. It's an international company. However, I'm also studying computational engineering at the University of Warsaw. We have at our university small division named, we call it ICM. It's the Institute for Mathematical and Computational Modeling. And we have HPC, of course, and we do very interesting projects, including my small contribution, which is my master thesis. Okay, so let's go through the agenda briefly. So first, I will give you a short introduction to the project, so what is all about it and why I'm working on it. I will also try to explain my motivation, why I think the topic is important. And then I will explain also research contribution, so what is the value of my project. And then I also spent few slides on the scientific approach explanation. So how am I going to work on it, how I'm working actually on it. And then, of course, I will try to give you some insights, conclusions, and I will refer to the future work. And I, of course, forgot that I would like to present you the topic of enhancing research through advanced scientific literature analysis. Sorry, that's stress. So, the topic is quite interesting. It looks maybe a little bit serious, and the title is long. However, I hope we will enjoy it. Okay, so. Moving on to the introduction, like I mentioned, this is my master thesis, actually the second master thesis at the University of Warsaw. So I already mentioned my affiliation, and I have also two core partners with this project. So it's System Biology Institute, SBI. They provided me some tools I use to achieve my goals in this project. And I also cooperate with the Medical University of Warsaw because my materials I'm working on, it's a topic based on medical experience and medical therapy named CAR-T. So I'm not medical doctor. I need some help with the medical expertise. I'm doing the technical part. However, someone needs to just check if my results are proper or not. So that's why I'm cooperating also with medical doctors from the university in Warsaw. Okay, and what is the motivation for this project? Why I'm interested in actually science of science, right? Science of science is the topic when we just trying to figure out how to do science better, how to do our research in a proper way, and what kind of tools we can use to make it better and easier with progress. So let's just think about researcher. For instance, I focus on medical doctors. On a daily basis, they work with patients, right? They have 8 hours or even more in hospital, and they work with patients. After this time, they need to go home or go to the office, and then they do research. Because they are medical doctors, they also need to do some research, especially at the university, cooperating with hospitals. So the thing is that they do not have much energy and time to do this research, to research papers, to find interesting insights. And that's the main motivation here for me. I would like to help them to make their work more efficient and to help them save their time. And what I want to propose is to use new technologies to just support them. Okay, and a little bit about research contribution. What is the value of the idea? What is the value? As I mentioned about medical doctors, so already you probably have an idea what could be the value. So the first value is to make research faster and also easier to progress. That's the main thing here. The second value is that using some automation and, for example, machine learning tools, we can also somehow find new, interesting and promising paths in science that human being can't do itself without help of machines, right? we have limited knowledge, we have limited energy, so we can't go through all literature or the collections of interesting literature. We also have some biases here. So for instance, most of researchers, they focus only on, the most important scientific magazines and articles, Science, Nature, and so on. However, especially for some niche topics, the important information that may do some, game change are also available in smaller magazines, in maybe not very promising articles, but still. So the second value is that we can just find new paths for our topic in science, and that could just move our research to different direction and change everything. So that's the second value. And also, what is important, we can support research institutions with development and organization research. We can also help them with some automation to better cooperate. I'm not sure if you know, but during COVID-19, until the vaccination was invented, a lot of research institutes, they had some problem with communication. So some automation here also could help to just do research faster and in a better way. And we can also support careers for young researchers, of course. And at the very, very end, from research, improving research methods, we can improve also business and industry, especially in engineering field. It's always like from the university, we are going to industry and business. Okay, so now I will talk about scientific approach. So first, where we are. I would say for now we are at the golden age of algorithms, of big data processing. And we have power, we have storage, and we have knowledge enough to do very interesting things with large language models, which are very now popular. Sometimes people call it also AI. I think it's maybe a little bit too much to call language models AI. However, we can also say like this. And it's a good time to just test and create new tools dedicated to text analysis, processing, and event generation, including new hypothesis generation. And what is the challenge here? The challenge is that we have different data formats here, right? So we have data in PDFs, we have abstracts in PDFs. However, we can also have data in a Word format, in CSV file, text file, and so on. So the first thing is that we need to focus on various data formats, including also pictures, tables, diagrams, and so on. The next challenge is to accessing relevant literature. Through the internet, we can find everything. So the problem is that sometimes we cannot find something valuable and suitable to our research. So that's the problem. We need to filter somehow the literature we have access to. The third thing is that we have still advancing like large language models, and in general, algorithmics is developing, right? So we need to learn it, we need to develop it, and we need just to follow it, right? Like my colleague before my speech said, each week we can just see, okay, something new appeared, something new we need to learn. So that's also the challenge here. And also the challenge is hardware and computing power. We have it for now, maybe not enough, but it's still good. However, we also need to think about sustainability, like mentioned before, and if this power computing is good enough for the future. Okay, we also need to think about the direction of valuable research work, and there is also some, impact in social and legal topics. So yeah, a lot of challenges. Let's go through this. In this diagram, you can see how we can extract new knowledge from the scientific literature. So let's start here. In this part of the diagram, we can see that at the very beginning we have unstructured data, scientific data, like I mentioned, right? And then we call it autocuration. It's a process of making this unstructured data structured. So here we have some natural language processing, algorithmic statistics, and so on, a bunch of algorithmics that we can use to make our data structured knowledge here. So after some auto-curation here, we can, for instance, from medical articles from databases like PLOS, PubMed, we can gain knowledge, which is, in this example, that's probably signaling paths for cell or some particle. And this is actually some knowledge. And for now, that could be surprising, but a lot of researchers, they do this auto-curation manually, right? So they just read papers and they gain knowledge and just trying to prepare and create something new from this. What we want to do is to help them, with some automation tools based on statistics and machine learning algorithmics. And moving on, so now we have this papers and papers and whole databases with papers, scientific literature. So we have a collection of literature. We did somehow knowledge extraction here, and then we have scientific knowledge in AI systems. So here is the space for now large language models. However, we have also different methods to generate text based on provided data. But let's focus on the large language models for now. So based on the literature, the knowledge extraction we put to the LLM, we can generate some new text. And the best goal is to generate some new knowledge as well. So just gathering what we have, the existing knowledge, we would like to achieve something new. We would like algorithm to create something new, some new knowledge, even new hypotheses. That's the best option here. And then, if we generate this new hypothesis, we need to verify them. So we go to the experiments, we just test our new hypothesis, and then we come back and saying, no, that's not good, or okay, that's fine, and we can create new paper and move to the database with relevant literature, right? So that's more or less the process of gathering, creating new knowledge, extracting new knowledge. And now what I'm doing in my research. First, materials. So I use a collection of scientific papers with the biomedical context, and this context is very novel CAR-T therapy. It's an oncological therapy. It's quite new. Researchers work on it since a few years, actually. It's not long for medicine. I'm analyzing most of the time abstracts in PDF format. And they are collected only from relevant sources, and they are updated daily from these sources. And a few words about CAR-T, why I've chosen this topic in medicine. First of all, because I think it's important. It's always in research to do something important and to achieve some important goals, right? So it's about human life, human health, so it's worth it to just focus on it. And what is very interesting in CAR-T, this therapy is not ready, but the clinical trials are very promising. However, there is still space to understand and to just discover some knowledge. For instance, CAR-T therapy is good for leukemia treatment. So some with the blood cancer is good. However, for solid tumors like glioma, it's not working well. For instance, we can also use CAR-T for allergic therapy and for even COVID. And we're still not sure fully why it's working for such diseases. So there is a space to see something new, to just discover something new. And why CAR-T is also valuable therapy? In most cancers, we use radiology or chemical therapies, right? Chemotherapy to just help the patient, right? But these methods also destroy human body cells, the healthy cells, not only cancer cells. So CAR-T is better because we use in a very, just to make it simple, we use own patient's cells, modify them, and put to the patient again. And these cells, CAR T cells after modification, they are fighting with cancer cells. So here we have specified, we can say that it's a specified therapy for cancer, right? So that's another pros of this topic. All right, and now what methods I'm trying to use. So like I mentioned, I collecting literature. I will explain how in a minute. Then I also use some tool I will refer to also in a minute to process this literature. I'm filtering information using algorithmics and statistics, and this is what is already done. And this last part is generating new knowledge. So that part is right now developing because of algorithmics in large language models is also developing. And that's the part most, I would say, ambitious here. So I'm going from scientific question. I'm keeping to ask some questions, scientific questions, according to CAR T therapy. And through this process, I'm trying to get some scientific answers, and I'm cooperating with medical doctors to just, see if these answers are good or no. Okay, a few words about the technical part. So how I'm trying to just filter and extract the knowledge from the data. Like I mentioned, SBI from Tokyo, Japan, they provided me a tool named Taxila. I call it scientific engine, and it's based on two parts. Taxila engine, which is the analytical part, and then we have also interface. Interface is user-friendly. It's software as a service, and just user can log in and provide some queries to ask scientific question, and then we can achieve some goals after processing in Taxila engine. So it looks like I'm taking Taxila based on the first attempt. It was based on HPC infrastructure in ICM. I was working with ICM instance, and here you have some information about the technical part of ICM HPC infrastructure. Right now, it's moved to cloud, so the instance I'm working on, we're working with now, it's also based on cloud, on AWS. So as we can see, cloud is getting more and more important even here. And so I'm using Taxila engine. I'm providing some literature, filtering from the databases I want. It's a PubMed, for instance. And then after that, I asking scientific questions using queries like SQL queries. So I'm just asking, okay, for instance, I want to find out in the bunch of articles topics with, I don't know, a keyword, stem cell, cancer, and blood, right? And after setting up this query, the scientific engine will filter for me relevant articles, and also will give me some statistics. For instance, how many times keyword is visible in this, such bunch of articles, the timeline, how many articles appeared in such a period of the year is also important. So we can just choose, thanks to this scientific engine, the best articles we are interested in. And then Taxila is also open to some modifications, so I'm also trying to use some implementation I'm doing by myself, including large language models. And I'm trying to get knowledge provided from the scientific engine. By request, I'm taking some results, and then I'm trying to combine it right now with the machine learning algorithms are available here right now on the market, right? So mostly I'm working with GPT. Also, I'm trying to use Llama and testing medical large language model from Google. It's a Palm. All right. So that's the technical part. We can see also some results here. So here is the full report we can achieve from Taxila. So you can see here, for instance, the period, the time period, and how many times the topics from our query is visible in articles. Here we can see some keywords. Here we can see, for instance, the databases from where we have the articles, and so on. We can create our own channels with topics we are interested in, and we can also these results save for later, so we do not have each time just to create new query and ask the same question many times. Okay. And here we can deep dive into the articles we find out. And here, for instance, we can start with one article we get from our query. And then from this one article, we can see connections between other articles. So we can just jump from one article to another, which are connected. And this is how we can, for instance, find new paths, new scientific paths for our research, right? So that could be really helpful. The second part is just grouping articles by topics or by from where they are published, and so on. So that's just some sample of results, and let's move to the conclusion and a few words about the future work. So the core question here is that can machine support researcher with his or her work, and even if there is a question if machine can create its own paper, its own research hypothesis, and even win the Nobel Prize. And that's a very risky question if the machines can just replace researcher. I think it's a better way to just see this topic as, machines and automation can support researchers, not replace them. That's here the main goal for me. And what is next? The next step is just to finish this work with large language models and just check if the generation of new hypotheses is really worthy to do the research deeper. So yeah, there's some sources, some literature if you are interested. And thank you so much for the Okay.
Thank you so much.
Thank you.
Any question from the audience? I will give you a microphone for you.
I always have a question. Thank you very much for your talk. I have a couple of quick questions. You mentioned that you base your NLP mainly on the abstracts. You don't analyze the whole paper, only the abstracts from PDF?
Yes, for now, for my research is small because text processing and analyzing the whole data from such a huge collection of literature, that could be time consuming and resource consuming, and I'm a student still. So that's why I'm focusing right now only on abstracts, but it's just for the first step for the test, right? For the just master thesis project purpose. I think in the future, and I also know that some companies, they also are trying to support their researchers with such very similar tools. So they are just working with the whole data in the literature. For me, it's just for some testing and see if my approach is correct or not.
And the second question is related to copyright, right? So one of the major challenges that we have is that most of the scientific papers are behind paywalls, like Springer or Elsevier or any other big company. Have you found this challenge, and how can we ensure that your algorithm has access to all the data, not just a subset that is just public research, right?
I think that's a little bit legal topic, and also a topic connected to social thing. I mean, there is a big question if the research, knowledge, and science should be open for everyone or should be closed because someone needs to be paid for it. In my opinion, it should be open for everyone. And yeah, I'm working only with open access, literature. And I hope in the future my approach will be more, understandable for big companies. Yes, we lost a lot of data for research, good data, because of money, and I wish that it's like this.
Okay, have a panel discussion afterwards. So let's thank again the speaker.
Thank you.